supported launch and mission operations. Next chart. Oh, before I leave that, I might mention to you that there were three very important causes. There were three very important causes of failure. One was workmanship, the other was design, and the other was contamination. Pardon?
Metal fatigue.
Metal fatigue, I don't believe was that much of a problem. It was more of a problem with aircraft than it was with the spacecraft. You're operating in a zero-G environment, and I don't think that was much of an issue. That's the reason why I don't like to answer questions during the presentation. I lost track of what I'm saying. So he's talking about design problems. Design problems, or workmanship problems, let me just mention that. Workmanship problems were ones which we could solve because they were things like we found cold solder joints, or we found a loose connection, something like that. We could correct that by improving our workmanship techniques and also certifying our manufacturing people so they were the best possible, best trained people that we could find. Workmanship, design type problems. Design problems were very serious because they really could affect not only the equipment that was involved, but if there was commonality, we'd have to correct the problem on all other spacecraft, and also possibly they might affect the command and service module. So, and it would mean that we'd have to replace something, we'd have to redesign, we may have to design a redundant leg so that if that leg failed, the redundant leg might be able to continue the mission. And finally, contamination was a very serious problem because of the fact that in a zero-G environment, you could have all kinds of particles floating around, finding their way into various areas. So it was important that we eliminate contamination in any which way we could. Among the way in which we could eliminate contamination was that we actually tumbled the lunar module prior to shipping it to the Cape for assembly into the Apollo vehicle. We tumbled the vehicle to find any loose objects or any kind of contamination that could find its way floating around in the cabin. Okay, the next chart is the one. Memorable events.
When Apollo 13 had the accident, they must have contacted you because that had a Lisbon land rather than in the capsule, correct?
I'm sorry. I can't hear you. Why don't we wait till the end? I'll ask them. Okay, memorable events. Well, in my career on the lunar program, memorable events were these. The first lunar lander, Apollo 13, Apollos 15, 16, and 17, which employed the lunar rover. I'll talk about that. July 7th, July 7th, 2007, that was well after the lunar program was ended. It was actually the 38th anniversary of the first lunar landing. NASA headquarters in Washington, D.C. asked Grumman to send a group of people to discuss lessons learned on the lunar program that could be applied towards the next manned space program. I was one of the 5 people who went and addressed those people in NASA. And the next memorable event for me was March 20th, 2010, when I received the Marconi Science Award from the National Italian American Society called UNICO. Next job. Okay, before I go to Apollo 13, let me talk about the first lunar landing. The first lunar landing Neil Armstrong was the commander of the mission. Buzz Aldrin was the limb pilot. Michael Collins was the command module pilot. The command module pilot remains with the command module in orbit during the lunar mission. Neil Armstrong determined that the designated landing site on this first lunar landing was unacceptable. So they had to seek an alternate landing site. What was memorable about Apollo 11 was the fact that here they are, they're coming down, descending, utilizing a descent engine is burning, utilizing fuel, and they're seeking the alternate landing site. And now the astronauts are counting down seconds remaining of fuel in the tank. By the time they touch down, memorable event, 11 seconds of fuel remained in the tank. Okay, Apollo 13. Apollo 13, and I'll mention to you, Apollo 13's commander was James Lovell. John Swigert was the command module pilot. And Fred Hayes was the limb pilot. On the way towards lunar orbit, an explosion took place on the service module. Service module, as you can see, very crudely. The service module had the explosion and rendering it, of course, unusable. So now the command module contains the fuel cells, and the fuel cells provided electrical energy and water, among other things, to this command module. The fuel cells combine hydrogen and oxygen, two highly volatile gases, to create electrical energy, and the byproduct is water, H2O2, water. Now, with the failure of the command module, we had to reconfigure the lunar module and the command module to provide water, cooling, and also equipment, oxygen, to the command module in order to conserve consumables on the command module on the eventual return to Earth, if that was possible. And in order to do that, the lunar module descent engine was used to launch the command module back to Earth. The service module gets jettisoned. And now I find that in reading an account of what happened on the lunar module, or on the command and service, command and lunar module, the three astronauts piled into the lunar module. They shut down every possible thing that they could shut down. The environment in which the three astronauts crammed into the lunar module were in, the temperature went down to 28 degrees. The humidity was 100%. The astronauts had to operate freezing, soaking wet during the time that they had to save themselves. Now here are, of course, three former test pilots. So, you know, they had encountered conditions somewhat like this, but never really down in operating at 28 degrees and 100% humidity, soaking wet. But, yes. the astronauts, being test pilots that they were, when that burn took place, and that burn of the descent engine took place on the dark side of the moon, so they didn't know whether they were going to, whether it was going to be successful or not, until the vehicle actually came back to within line of sight of the Earth. And among the comments that some of the astronauts had made was, well, we had nothing else to do while we had that burn, so we decided to take pictures of the backside of the moon. And also they had discussed and said, well, there's a possibility that this burn would not get us back within the gravitational field of Earth, and therefore pull us back towards the Earth. We might be flying off into space, so we might as well collect as much data as possible before all our consumables ran out. Certainly, Apollo 13 was very memorable. It never completed its lunar mission. It certainly at least completed its crew safety mission. In the end, the command module did come back into the Earth's atmosphere and parachuted and landing in the routine recovery mode down onto the ocean. So that was the next memorable event. The other memorable event were the next chart, the landing, the lunar rover. Now the lunar rover was deployed it was strapped onto the descent stage of the lunar module, and was actually, from what I understand, deployed on the lunar surface manually by the astronauts by a means of latches and D-rings and other mechanical ways. They were able to deploy the lunar rover down to Earth. And I'll read some of the specifications on the lunar rover. 467 Earth pounds in weight, empty, 77 pounds lunar weight. The total loaded weight was 1,600 pounds. The length was about 10 feet. The width was about 6 feet. The wheelbase was 90 inches. The ground clearance was 14 inches. The turning radius was 10 feet. The maximum speed was 8.7 miles per hour. The power supply was supplied by two 36-volt silver zinc batteries. The traction drive, the drive was actually 4 quarter horsepower DC motors, which actually were attached to each of the wheels that supplied the drive for the vehicle. What else can I tell you? The maximum excursion, the maximum total excursion for the lunar rover, probably based on the strength of the batteries, was 57 total miles. But any given mission was no more than 6 kilometers or 3 miles. And that was probably based on the fact that that would be the furthest that they would expect the astronauts to be able to hoof it back to the lunar module if they had to walk back, if that lunar rover failed at its furthest point in the mission. So anyway, that is the lunar rover, and I'll just point out some of the items that are on the lunar rover. A high gain antenna, a low gain antenna, the TV camera over here.